Hi everyone, I'm Anqi from Zhejiang University. Today I will introduce our paper, Team Builder Toward More Effective Lab Selection in Soccer. In soccer matches, lab selection is to select the most suitable 11 players from the squad of a team. The selected players will form the lineup, and other players will be the substitutes for the match. It is an essential and important decision-making task for soccer coaches to increase the chance of winning the match. Selecting a good lab is not a trivial task. Coaches need to choose players and various criteria and through multiple comparisons among the players' performances, with the consideration of multiple factors such as the opponent team and the tactics to apply. This process usually involves extensive data analytical activities. Recently, various computational tools have been proposed to help coaches find suitable labs based on player performance, match winning rate, and player teamwork. However, these methods mainly use complicated models to generate the best lab automatically and often overlook the tactical inputs from coaches. Interactive visualization systems have been available for the analysis of soccer data, such as statistical data, event data, and trajectory data. However, they hardly support visual analytics for soccer lab selection. Tools for interactive lab analysis and selection are still rare. In this research, we propose a visualization system, Team Builder, to provide a systematic solution for the lab selection problem. In the tactic view, users can explore tactics expected to be used by the target team. In the player view, users could acquire a lab generated by the model and conduct further investigation and comprehension. In the lab view, users can compare labs and find the best lab and the multiple criteria. We encountered two main challenges during this research. The first challenge is characterizing and modeling the complex factors that should be considered in lab selection. In soccer matches, lab selection is influenced by both the performances of individual players and the offensive and defensive teamwork among players. The lab selection model should consider these complex factors. The second challenge is designing a systematic tool to assist soccer coaches to make the best lab decision. The tactical preferences of soccer coaches could vary significantly, and the coaches also need to evaluate the selected labs through the comparison on different aspects. The system should allow interactive control over tactical inputs and visual comparison of players and labs. To solve the first challenge, we develop a new teamwork-based model to integrate key factors for lab selection. For each player, we calculate a teamwork value, including the player's individual performance, offensive interaction with the teammates in the lab, and defensive interaction with the opponent players. To calculate the interaction values, we divide the soccer match into different phases based on the transition of possession. A phase is a series of consecutive actions performed by players in the same team. An offensive interaction is composed of two consecutive actions by two players in the same phase, and the defensive interaction is two consecutive actions of players from different teams. The interaction value is the sum of the values of the two actions within the interaction. Finally, we solve the optimal lab by maximizing the teamwork value of the selected 11 players through integer linear programming. We consider important constraints in the optimization process, including the total player number, the players manually included by coaches and who cannot appear in the match, and the team formation. To solve the second challenge, we worked with 3 soccer experts and developed design requirements at 3 levels: tactic level exploration, player level investigation, and lab level comparison. On tactic level exploration, We design a tactic view to filter tactics with essential tactic categories and navigate the tactics to be applied for the match. The tactic view is composed of a confrontation tactic list to present all tactics used by the target team and its opponent. On the top of the list, we use distribution bar charts to present the usage rate and success rate of all tactic categories. Users can select categories of tactics that appear in the list for further tactic specification. Then users could explore confrontation tactics in the selected categories through ranking and filtering tools. Users can click the tactics of the opponent team in the left list to filter the confrontation tactics of the target team in the same spatial region. Then the tactics of the target team in the right list can be selected for different player roles. The tactics are visualized by tactic diagrams based on the aggregation of phases or actions on similar spatial regions. After the tactics are specified, the value of interactions included in the chosen tactics will be allocated with an elevated weight. Thus, the players who perform well in the selected tactics will be more likely to be chosen. On player-level investigation, we design a player view to explore player performances and investigate the interactions among the players to explain the generated lab. In the player view, users can explore player performances in the candidate player list with player matrix, including the individual performance value, the total offensive interaction value, and the total defensive interaction value. Then users can select players included or excluded in the lab and generate lab and further adjust it in the lab edit board. After the lab is selected, users can explore the detailed interaction values of each player with the explanation component. The interaction values among the players are represented by a matrix and encoded by the area of rectangles. In the offensive interaction mode, the individual performance and the total defensive interaction values of each player are illustrated by bars. On lab level comparison, we design a lab view to identify the most suitable lab with visual comparison on multiple criteria. In the lab view, users can record multiple selected labs in the candidate lab list and compare the labs according to different criteria. Each row of the list contains the predicted match result and the confidence score of the lab to help users decide on the most suitable lab. Besides, users can click to show the thumbnails of the labs to present the lab details and the confidence score of each player. The candidate lab list also provides the predicted statistic indicators for each lab to help evaluate whether the tactical characteristics of the lab meet their expectations and facilitate the choice of suitable match strategies. We evaluate our lab selection model with 2 experiments and the system usability with 2 case studies. We also interviewed the 2 experts in the case studies and another 2 new experts to evaluate the usefulness and effectiveness of our system. All the experts were satisfied with our system and provided some suggestions for improvement. In conclusion, we characterized the domain problem of soccer lab selection, develop a teamwork-based model for lab selection, and design a visual native system to support lab selection process. In the future, we will enhance the lab selection model by considering more data types and extend our work to other team sports such as basketball and baseball. That concludes my presentation. Thank you.